What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what the OSPF routing protocol is in case you have no idea. So let's get into it. If you're just diving into the world of networking or you're studying for a certification like the CompTIA Network Plus or Cisco CCNA, then you probably heard the term OSPF tossed around. It's one of those core routing protocols that keeps the internet and large networks running smoothly. But what exactly is it? Why do IT pros care so much about it, and how does it actually work? Well, I'm going to break all of this down for you, and we're going to explore everything that you need to know about OSPF. All right, so let's start simple. OSPF, this is a routing protocol. Its job is to help routers decide the best path to send data across a network. So think of a router like a traffic cop for the internet. It's constantly making decisions about where to send packets of data so they reach their destination as efficiently as possible. But to do that, it needs a solid understanding of the quote-unquote roads or network links and traffic conditions or link speeds and congestion. And that's where OSPF comes in. So OSPF, this is a link state routing protocol. It basically uses a map of the entire network to figure out the shortest, fastest path from point A to point B. All right, so exactly why is it open? And why does it use shortest path first? Well, open, this means that it's an open standard. So unlike proprietary protocols like EIGRP, which is Cisco specific, OSPF works across different vendors and platforms. And you can run OSPF in Cisco, Juniper, Linux, Windows, you name it. And shortest path first, this refers to the algorithm that it uses. And this clever math-based process basically figures out the shortest or least cost path through a network. So when you hear of OSPF, just think open protocol plus smart pathfinding equals efficient routing. All right, so understand that OSPF is not the only protocol in town. There are various other routing protocols like RIP, which stands for Routing Information Protocol. And basically RIP is simple and easy to configure, but it uses hop count and maxes out at 15 hops. And it's basically good for small networks. Then you also have EIGRP, and this is more advanced and efficient than RIP, and that is Cisco proprietary. You also have what is called BGP, or Border Gateway Protocol, and this is a big player for routing between ISPs across the network. And then you have what is called intermediate system to intermediate system, and this is similar to OSPF, but more common in large ISPs. So out of all the routing protocols, why would you choose OSPF? Well, it scales really well, it converges quickly, it's vendor neutral, and it's super detailed when it comes to understanding the network topology. Now, before we dive deeper into OSPF's inner workings, we need to get a handle on link state routing versus distance vector routing. So here's a quick analogy. So distance vector routing, like the RIP protocol, this is like asking your friend for directions and trusting what they say, even if they got the information from somebody else. Link state routing protocol like OSPF, this is more like looking at a detailed map yourself, then deciding the best route based upon what you see. So basically, OSPF doesn't just take someone else's word for it. Each router builds its own map of the network using something called a link state database, or an LSDB. All right, so let's tackle some of OSPF's important concepts in a way that actually makes sense. The first concept we're going to talk about are areas of hierarchical design. So OSPF is designed to be scalable, and to do that, it breaks networks into areas. You have what is called area 0, and this is called the backbone area, and all other areas connect to it. And the other areas, which could be area 1, 2, 3, etc., these are like neighborhoods connected to the backbone. Now, why do we break these things into areas? Well, it reduces the size of the LSDB and limits how far link state updates have to travel. So in other words, it essentially keeps things neat and efficient. And then we have different router types. So there are different router roles in an OSPF world. You have what is called the internal router, and this lives within a single area. You have the backbone router, and this lives in area 0. You have what is called an area border router, or an ABR, and this connects one or more areas to the backbone. And then you have what is called the ASBR, or the autonomous system boundary router, and this connects OSPF to another routing protocol like BGP or RIP. And you could think of ABRs and ASBRs as the network's border control agents, where they handle the flow of information between different territories. All right, so let's discuss OSPF in action. So how this all works is like this. You got step 1, which is called router discovery. And this is when a router comes online. and it uses hello packets to find other OSPF speaking routers on the same network. It sends these packets out to all OSPF enabled interfaces, and if another router responds, they try to become neighbors. And then step 2 is called neighbor adjacency. So not all neighbors become best friends. In OSPF routers, they must pass a few compatibility checks first, such as, are they in the same area? Are they on the same subnet? Do they have the same hello dead interval? And they have to ensure that there is no authentication mismatch. And if all goes well, they form an adjacency, which is like a close friendship, where they'll exchange detailed information. And then after that is step 3, where they exchange LSAs, or link state advertisements. So routers, they start sharing LSAs, which describe their connections, such as interfaces, neighbors, costs, etc. And LSAs, basically, they flood the area, allowing each router to learn about the entire network. And then that leads us to step 4, which is building the LSDB. So each router compiles the LSAs into a link state database. And this is basically a map of the entire network. And then step 5 is the shortest path first calculation. So using that algorithm that we talked about earlier, the router calculates the shortest path to every other router in the network. And this creates the routing table, which is also known as the forwarding database. And once you have all of that established, then guess what? You're essentially routing. All right, so let's go ahead and talk about OSPF metrics. So OSPF uses cost as its metric, and the cost is calculated based on the bandwidth of a link. And the formula is written right here in red for you. And so basically a fast link, like a 1 gigabit per second connection, this has a lower cost than a slower one, like a 10 megabit per second connection. And basically the shortest path is the one with the lowest total cost, not necessarily the fewest hops. All right, next let's talk about OSPF packet types. So OSPF uses different packet types to get the job done. So here's a quick rundown. You have what is called the hello packet, and this establishes and maintains neighbor relationships. You have the DBD, or the database description, and this describes the contents of the LSDB. You have the LSR, and this is the link state request, and this requests specific LSAs from a neighbor. You have what is called the LSU, or the link state update, and this delivers the LSAs. Then you have the LS acknowledgement, or the link state acknowledgement, and this confirms receipt of the LSAs. So you can think of these like different types of messages in a group chat. When it comes to the hello packet, it's basically saying, hey. When it comes to the DBD, it's basically saying, here's what I know. When it comes to the LSR, it's saying, can you resend that? When it comes to the LSU, it's saying, got it. And when it comes to the LS acknowledgement, it's saying, thanks. All right, so let's move on and talk about OSPF convergence. So convergence means all routers in the network agree on the best paths. And this is where OSPF shines because it converges fast. And when a change happens, like a failed link, OSPF will detect the change via lost hello packets. It'll update its LSDB with new LSAs. It'll then recalculate the best path using that algorithm we talked about earlier. Then it'll update the routing table. And all of this happens quickly, usually within a few seconds, which is way faster than the RIP protocol. All right, next let's quickly talk about some OSPF versions. So there are 2 main versions of OSPF that are in use today. You have OSPF version 2, and this was designed for IP version 4. And then you have OSPF version 3, and this was designed for IP version 6, but it can also support IP version 4 with extensions. And OSPF version 3, this includes better support for security and address families, but fundamentally it works the same as OSPF version 2. All right, so let's quickly talk about authentication and security when it comes to OSPF. So OSPF isn't just about fast routing. It's also about secure routing. So you don't want rogue routers just joining your OSPF domain and messing up your routes. So OSPF supports authentication, such as null authentication, which is basically none. It supports plain text authentication, which basically secures it with a simple password. And then it also supports MD5 authentication, which is much more secure. And also in OSPF version 3, it offloads authentication to IPsec, which is more secure and modern. All right, so let's talk about some design practices for OSPF networks. So if you want your OSPF network to be rock solid, then go ahead and follow these tips. You want to use areas wisely. So do not put everything in area 0 unless it's a very small network. Always summarize routes at the ABRs because this keeps routing tables small. Avoid too many neighbors on a broadcast segment. So use point-to-point links or reduce the DR/BDR elections. You want to set your interface costs manually for better control. You want to plan your network logically. So basically, do not mix voice data and management on the same segment. And to kind of help you all visualize this, let's just imagine that you have 3 sites. You got your headquarters, your East branch, and your West branch. Now, each site has multiple routers. Your headquarters is your area 0 or your backbone, and your East and West are areas 1 and area 2. And also, each branch connects back to the headquarters. Now, each router runs OSPF. They exchange hello packets and form neighbor relationships. They flood LSAs within their same area, and the ABRs between the headquarters and each branch summarize routes and pass information to Area 0. Now, if the link between the headquarters and West branch fails, then OSPF will quickly recalculate and reroute through the East branch if that path exists. And essentially, that's the magic of dynamic routing in action. All right, next, let's talk about some common OSPF troubleshooting tips. So if things aren't working, here's what you can check. You can check for mismatches and hello dead timers, because this will essentially prevent routers from forming neighbors. You can check for authentication errors like MD5 password mismatches or no hello packets. You can check for area mismatches, because routers, they must be in the same area to form an adjacency. And you can also check to see if there's no network statement, because if you forget to enable OSPF on the interface, it won't advertise it. Then you can run these commands right here, like show IP OSPF neighbor or show IP OSPF interface, and debug IP OSPF in order to help you diagnose any problems. Now, exactly why should you care about OSPF? So whether you're studying for a certification, building a network in your home lab, or managing enterprise routers in the field, then OSPF matters, because it's everywhere in enterprise LANs and wireless LANs. It's open and vendor neutral. It scales like a champion. It recovers quickly from failures. And it just works once you understand how to set it up. Now, if you learn OSPF well, then you'll understand the core logic behind most dynamic routing protocols like EIGRP or even BGP. So here are the key takeaways. OSPF might seem intimidating at first because you're talking about areas, neighbors, LSAs, DR, BDR elections, and all this other stuff. But once you break it down, it's just a beautifully structured system that solves real-world routing problems. It's like learning how to read a map and direct traffic. And once you get the hang of it, it becomes second nature. So if you're just starting out in networking, then don't be afraid of OSPF. Embrace it, build a lab, fix it, and watch the neighbor relationships form. Run the show IP route OSPF command, change interface costs, and see the routing table shift. Because once you understand how OSPF thinks, you're not just learning a protocol, you're learning how networks think.